Bismillahirrahmanirrahim. We are going to start question number 17 of exercise 4.1, which is an equals to log 10 raised to the power n, and we have to find the 43rd term. So, okay, power comes in front of the log, so we are going to write it as an equals to n log 10, and log 10 is equals to 1. Log 10 equals 1. So an equals to n here is 43, and so a 43 equals to 43. Now question number 18 is an equals to ln e raised to the power n, and we have to find 67th term of this sequence. So again, n comes in front because this is the property of log, that whenever there is a power, it comes in front of the log. So an equals to n ln e. Ln e is equals to 1. So an equals to n into 1. Now n is supposed to be equals to 67. A 67 equals to 67. Now, in the rest of the questions 19, 20, 21, and 22 of this exercise, we have to predict the general term or nth term of the given sequence. So we are given with the sequence and we have to find what its nth term would look like. So let's see the first one. It is 1, 3, 5, 7, 9, and we know that this is the sequence of positive odd numbers. It is the sequence of positive odd numbers. So what are we going to do? For even numbers, it is going to be 2n. You understand? So for 2n, the first term will be a1 equals to 2 into 1, which is 2. a2 equals to 2 into 2, it is 4. So a3 equals to 2 into 3, it is equals to 6. This is for even numbers. Okay. Now we have to work for odd numbers. So how is that going to be? We are going to subtract 1. Now let's find. It is for odd. Wait for a while. For even numbers, it was 2n. For odd, it would be 2n minus 1. So a1 is going to be 2 into 1 minus 1. It is equals to 2 minus 1 is 1. Now a2 is equals to 2 into 2 minus 1. It is equals to 4 minus 1, which is 3. a3 equals to 2 into 3 minus 1, which is equals to 2 3s are 6, minus 1 is 5. So this is the sequence of odd numbers, which is 1, 3, 5, then 7, then 9. So what is its answer? It is 2n minus 1. So for question number 19, it is an equals to 2n minus 1. Okay. Now let's see question number 20, which is 3, 9, 27, 81, 43. Okay, here it is much visible. 3 raised to the power 1 is 3, 3 raised to the power 2 is 9, 3 raised to the power 3 is 27, 3 raised to the power 4 is 81. So 3 raised to the power any number will give us an. So when this n and this n are same, it will give us the result. So a1 equals to 3 raised to the power 1, which is 3. This is the first term over here. Now a2 equals to 3 raised to the power 2, which is 9. a3 is equals to 3 cube, which is 27. a4, which is 3 raised to the power 4, it is equals to 81. So it goes on like this sequence. So for question number 20, we have an equals to 3 raised to the power n. Now we have question number 21, which is square root of 2, square root of 4, square root of 6, square root of 8, and square root of 10. So square root is common. Let's write square root. And inside the square root, we have all the even numbers 2, 4, 6, 8, and 10. So for even numbers, it was 2 into n. Now a1 equals to square root of 2 into 1, which is equals to square root of 2. Then a2 equals to square root of 2 into 2. So it is equals to square root of 4. Then a3 equals to square root of 2 into 3, which is equals to square root of 6. So it's just like this sequence. So question number 21, it is equals to, okay, it is an equals to square root of 2 into n. Question number 22 is as simple. We can see it is 1.2, then 2.3. So the first number is n. N is 1, it is 1, 2, 3, 4. So the first is going to be n, a n equals to n. And the second number, there is a dot in between. And then the second number is n plus 1. So n plus 1. It is 1 plus 1, which is 2. Then when n is 2, then 2 plus 1 is 3. When n is 3, 3 plus 1 is 4. So it goes on with the sequence. It was simple. So we are going to write it over here. Question number 22. A n equals to n dot n plus 1. Thank you so much.